So what we're going to do in this video is we're going to graph a polynomial function using um, some tools along the way. We're going to be using end behavior, we're going to be using the zeros of the function, and we're going to be using multiplicities of zeros to help us graph this polynomial function. Okay, so what we're going to do is, here we're starting off with this polynomial. It's a 6-degree polynomial. Okay. And we want to graph the function. And so what we'd have to do is we first have to factor it, or find the zeros, because really that's what we need to do when we graph polynomial functions, is get down to the zeros. So let's just say by magic we did a lot of work ahead of time and we used the rational roots theorem, and we found that this thing factors like this: f of x equals x squared times x minus 3 to the third times x plus 1. Okay, so like I said, if you look at the video just before this one, or if you look at the video for rational roots theorem, you would be able to see how you could actually go from the original to this one. Okay, but that's not the point of this video. Okay, so we factored it, we found the zeros, we factored. So let's list the zeros. So in this case here, the zeros are going to be x equals 0, x equals 3, and x equals -1. And we say 0 is a zero of multiplicity 2 because, you know, this is really x times x, and that means that x equals 0 occurs twice. X equals 3 is a zero of multiplicity 3 because that factor appears 3 times, so x equals 3 is a 0 3 times. And then x equals, oops, I'm sorry, that's not the right thing I want to do. X equals -1 is a zero of multiplicity 1 because it only occurs once. Okay. All right. So we'll be coming back to multiplicities in a second. Okay, so now, at this point, now what I'm going to do is I'm going to make a number line. Okay, and this number line is just to keep track of what's going on in between these zeros. So let's plot x equals 0, x equals 3, and x equals -1. All right. Now, then what we can do here, we're going to do, you know, there is a shortcut through all of this, and I'll talk about that here in a little bit. But what you should do, let's suppose you forgot about how to do the shortcut. What you should do is you should pick points here. Let's say x equals -2, x equals -0.5, and what I'm doing is I'm picking these numbers in between the zeros. I don't pick the zeros themselves, I pick in between the zeros because I want to know what's happening in between them. All right? And say x equals 1 here, and x equals 4. All right. And then what we're going to do is we're going to sub these numbers into the original function. I think, and what I want to focus on here is the factored form of the polynomial. All right. And we're just going to keep track of the signs. All right. So let's start with -2. All right. So I'm testing something to the left of -1, so -2. So if I sub in -2, notice for every one of these numbers, the first factor, x squared, is always going to be positive. So I'll put a positive there. It's always positive because it's being squared. Okay. All right. So now let's suppose we sub in a -2 into the second factor. If I sub in a -2, that'll be -5, -5 to the third. Well, anytime you cube something negative, it's still going to remain negative. So that'll be negative. Okay. What happened there? Okay, that'll be negative. Now, if I sub -2 into x plus 1, that's still going to be negative, right? -2 plus 1 is still -1, so that's negative. So if I keep track of these signs, I have a positive times 2 negatives, which is a positive. Positive times a positive is a positive. Okay, so now everything to the right is positive. All right, let's move on. What about in between -1 and 0? Okay, so I'm keeping this first factor positive, because remember, it's always positive. I'm always squaring. Now, if I sub in -0.5, well, this second one is still going to be positive. You see that? So when I sub in -0.5, sub in -0.5, that's going to be negative. When I cube a negative, that's negative. When I sub in -0.5 into the third factor, x plus 1, that's -0.5 plus 1, that's going to be positive now. And now notice here, I have two positive and negative. The product's going to be negative. All right. Okay. So let's move on to the second. So what about in between 0 and 3? Okay. Well, if I use x equals 1, positive here, I sub in a 1. 1 minus 3. Still going to be negative, right? 1 minus 3 is negative 2. Negative 2 cubed is still going to be negative. And I sub in a 1 here to the third one. Keeps doing that. Keeps erasing. Sub in negative 1, I'm sorry, positive 1 into the third factor. That's going to be positive. And notice here we have positive, negative, positive. That's going to be negative still. Okay. All right. Moving along. Okay. So let's suppose now we choose x equals 4. Well, now look what happens. So the second factor, 4 minus 3 is positive. Positive cubed is going to be positive. And then when I sub 4 into the third factor, that's also going to be positive. So the product of three positives is positive. Okay. Now just a little note here. What this means is that what am I doing here with the positive, negative, negative, positive? Okay. Well, there's something we call the intermediate value theorem, and the intermediate value theorem says that if a function has a 0, then it changes signs. Then it may change. It doesn't have to change, but it may change signs before and after, and that's what we're testing for. We're testing to see if this thing is going to change or not change. Okay, but we do know that at the zeros, the graph will hit the x-axis at those numbers. Okay, so by saying that it's positive, this means that it's above the x-axis, and by saying that it's negative, this means it's below, below, and above. Okay. Now, let's go to sketching the graph. Now, I'm going to sketch the graph. I guess I'll put it right here. Okay, right off to the side to keep it all together. Okay. So now, I'm going to transfer this information over here. So let's say I plot my 0. So I have 0, I have, let's say, 1, 2, 3, and then I have negative 1. Okay. Now, here's how this goes. So I know that from, let's say, negative infinity up to negative 1, which is all of this right here, I know it's above. So, but it's got to come down towards the 0. So it's going to come down towards this 0 and touch. Now, in between negative 1 and 0, it's negative. That means it's below the x-axis. So it's going to come below the x-axis now. And at some point, it needs to turn because it has to come back up towards this 0 at 0. So it's got to turn. We don't, oops, that's a little messy there. Let me fix that. Like that. Okay, so let's do that over. So it's got to turn at some point, coming right back up, like that. Okay, well now what happens? Well, it hits 0, and then it bounces right back off. Well, it's still negative, so it comes up, hits again, bounces right back off, and then it needs to turn, it's below, and then we know that it's got to come back up towards the 0 at 3, so at some point it's got to turn and come back up. Okay, and then after 3, it says that it's above, so now we just come above and we stay above. Okay, so there we go. All right, and that's the graph of the functions. It's really not that bad. Once you kind of just get the idea of what you need to do, and you understand how to use this number line here, graphing a polynomial function is easy once you know the zeros. Okay. Now, really quick, I want to talk about how we could use the multiplicities to graph. Well, we've discussed before in class that if a 0 has an even multiplicity, like it's 0, then I know that it's going to bounce. Okay. And if a 0 has an odd multiplicity, then I know it's going to cross. So at these two zeros, they cross. You see that? Okay. Now, I can also use the end behavior. Where can I put that? I guess I can try to squeeze it, I guess over here in the corner. Let's say up here, end behavior. And let's see, behavior. Now, the end behavior, remember, if a function has an even degree. Notice in this case, it's degree 6. So that's even. Good. And if the leading coefficient is positive, well, the leading coefficient is positive. Good. Okay, well, what does that mean? Well, if we look here, the degree is even, leading coefficient is 1. So, if that's the case, then what happens is we know that the graph's going to point up in in both directions. Now, in between, I don't quite know. It might do whatever it needs to do, but I know it's towards the end, as x goes to negative infinity and positive infinity, I know it's going to point up. Okay, so how can I use that in my graph? Well, look at my number line. You see how the end behavior is here? It says it's pointing up. That means it's above the x-axis. Well, look at the ends here. It's positive, positive. You see that? Okay. All right, good. So I could have wrote that down right away, immediately, once I looked at the degree and the coefficient. Okay. I also know that the only time the graph is not going to cross is at x equals 0, because at x equals 0, the multiplicity is even, so I know it's going to bounce. Okay? So what does it mean to bounce? Well, what it means to bounce is that whatever the sign is before, it's going to have the same sign right after. So notice here at 0, we saw that between -1 and 0 was negative. So that means that if it bounces, then after it's also going to be negative, which was the case here. As you see here with the graph, it bounced right off of that 0. But everywhere else it crossed, meaning it's going to change signs. So if it crosses, that means it changes signs. So see here at -1 and 3, those both had odd multiplicities that crossed. Well, look at the signs. At -1 went from positive to negative, and at +3 went from negative to positive. So that's how you can use that information to graph. I mean, you don't even need test points at that point. Once you know the multiplicities, the end behavior, you're set to go with your number line. Okay.